In 2.4, we're working with solutions of linear inequalities. A linear inequality in the variable x as an inequality can be written in the form of ax plus b greater than 0, where a is not equal to 0. We use these inequality symbols of greater than equal to, less than, or less than equal to. The steps used to solve a linear inequality are the same as those used to solve a linear equation, except that the inequality symbol is reversed if both sides are multiplied or divided by a negative number. Let me speak about that first. If I had something like negative x is greater than 2, and I divide both sides by negative 1 in order to isolate my x, I must flip the inequality sign. The reason is that inequalities are directional statements. The other way to do this would be to add x to both sides, then subtract 2 from both sides, and then you have this statement that you have to read backwards: x is less than negative 2. So picking that whole thing up as if it were written on glass and flipping it over, you would have x is less than negative 2, where you've written it where it's not backwards anymore. So instead of going through all of these steps every time, we simply remember that if you multiply or divide by a negative, that you have to flip the inequality sign. Let's try with this problem here, solving the inequality. We're going to subtract x from both sides. So I have 2x minus 1/3 is less than equal to negative 4. I'm going to add 1/3 to both sides of the equation. That gives me a 2x is less than equal to negative 3 and 2/3. So that's going to be a negative 11/3. Now if I multiply both sides by 1/2, then I'm going to get my x by itself, and that gives me a negative 11/6. Notice I did not flip my inequality sign. I was multiplying by a positive number on both sides. On the right side, of course, I multiplied a negative number, but I didn't multiply by a negative number. I multiplied by a positive number. So this is the answer to that inequality. Example 2 is on profit. For an electronic reading device, the weekly revenue and weekly costs in dollars are given by R of x equals 400x and C of x equals 200x plus 16,000, respectively, where x is the number of units produced and sold. For what level of productions will a profit result? We will have a profit when the revenue is greater than the cost. So we simply substitute what R of x equals and what C of x equals, and for our R of x and C of x, and we have our inequality statement. We're going to subtract 200x from both sides, then divide both sides by 200, and x is greater than 80. So we say more than 80 units must be produced and sold to have a profit. Would not be correct to say that we have to produce and sell at least 80 units. If we said at least 80 units, that it means 80 units or more. In fact, 80 units will not give us a profit. 80 units is the break even for this example. In example 3, we're figuring the body temperature. A child's health is at risk when his or her body temperature is 103 degrees Fahrenheit or higher. What Celsius temperature reading would indicate that a child's health was at risk? Recall, Fahrenheit is equal to 9/5 C plus 32. So our 103 degrees Fahrenheit is going to substitute in for F, and we know that that is 9/5 C plus 32. That Celsius temperature, if it's more than the 103 or equal to 103, that is going to be our temperature that is going to leave our child's health at risk. What we'll do is go ahead and subtract 32 from both sides of the equation. That gives me a 71 is less than equal to 9/5 C. Then I multiply both sides by 5/9. Multiply by 5/9. And that's going to give me C greater than equal to 39.4 degrees. So a temperature of 39.4 degrees Celsius or higher indicates the child's health is at risk. In example 4, we're going to use our graphing calculator. We're working this using the intersection method of solutions. So we're going to make the left side of our inequality y1 in our calculator, and we'll make the right side of the inequality y2 in our graphing calculator. So go to y equals and put in your calculator. You can press alpha y equals to get the fraction menu if you have that operating update. If not, put your entire numerator in parentheses, and then 4x minus 7 over 8 for the second part. We don't know where this is going to graph, so let's start with the standard window, and that worked well for us. So we see the intersection there. Let's go ahead and calculate where that intersection is, curve 1 and curve 2. And we get this intersection get this picture for you so we can blow that up and talk about that a little bit more detail. And so what I have here is that break even is at that point of intersection. That is where y1 is equal to y2. That value is an x value of negative 2.55. In our graphing calculator, y1 was the blue graph and y2 was the green graph. So we want to know where the blue is bigger than the red graph. Okay. In other words, remember, y is in charge of the height of a graph, or the upness and downness of the graph. So we want to know where the blue graph is above the red graph? Where is the blue graph above the red graph? And we see here that it's X values of here and on would give us where the blue graph is above the red graph. So our break even here at negative 2.55 and X values to the right of that would make our blue graph above the red graph. So X greater than or equal to negative 2.55. In example 5, again, we're going to work with the graphing calculator. During a recent summer, Dallas, Texas endured 29 consecutive days when the temperature was at least 100 degrees Fahrenheit. On many of these days, the combination of heat and humidity made it feel even hotter than it was. When the temperature is 100 degrees Fahrenheit, the apparent temperature A, or heat index, depends on the humidity H, expressed as a decimal, according to A equals 90.2 plus 41.3 H. For what humidity levels is the apparent temperature at least 110 degrees Fahrenheit? What we want is to make this temperature, the apparent temperature, feel at least 110 degrees. So 90.2 plus 41.3 greater than or equal to 110 degrees. Our apparent temperature, or the heat index, is what it feels like. Feels hotter when it's more humid. What we'll do is put this into the y equals of our calculator. So we have 90.2 plus 41.3 x. I didn't write my x over here, my h in the problem. And we want 110 for the other side. As far as setting our window, we know we're not going to have a negative h, which is our x in the calculator. We're not going to have a negative level of humidity, so we'll go ahead and just start that at 0. And we know that our humidity H is expressed as a decimal. Since it's expressed as a decimal, the most we can go is 100% or 1 as a decimal. So let's go ahead and put 1 there. Then we can do a zoom and down to zoom fit. There we see the intersection. Let's find that intersection. Second, calculate 5, enter, enter, enter. And the intersection is 0.479. So 0.479 is where it feels equal to 110 degrees. Now, look back at your equations. This was the equation that we put in blue, and the 110 is graphing for us in red. So when we go back to our graph, we're wanting to know where the blue graph is above the red graph. That would be from here over. So we have values of where it intersected at the 0.479 and more. So H is greater than or equal to 0.479. And if we want to express that as a percent, we would say 47.9% humidity or higher. will make 100 degrees feel like it's 110 degrees or more. For example 6, we're talking about course grades. The student has taken 4 tests and has earned grades of 90%, 88%, 93%, and 85%. If all 5 tests count the same, meaning they're equally weighted, what grade must the student earn on the final test so that his course average is a B? That is, so his average is at least 80% and less than 90%. Well, let's think about how we would figure out what the average is. We have 90 and 88, 93, 85, and a score on a test we have not taken yet. If we divide those numbers, add it up by the number of numbers, that's going to give your average. We want that average to be at least 80%. So we want that score to be greater than or equal to 80, but less than, strictly less than 90. We want to know what grades it would be for us to get between 80 and 90, including the 80. Let's go into y equals, and we'll put in our middle 90 plus 88 plus 93 plus 85 plus our variable x, and we're dividing by 5. Again, double check and make sure it looks like I have an extra 8 up there. I'm going to take that out. And then I have an 80 and a 90. There we go. And let's see, where would we graph something like this? Minimum of 0, max, let's say we max out at 100% on the test. We should be able to find the intersection there. Do a zoom fit, and indeed we see the intersection of the grades they're making and the limits between the lowest grade for an 80 and the highest grade to be up to 90%. So let's go ahead and find the intersection. We're going to calculate the intersection. We want, let's do our lower first, the 80. So we're intersecting the middle part of our inequality with that red graph, the 80, and we get 44. So 44 is less than equal to x, which is strictly less than. We'll find the intersection again. First curve is the blue one, but now the second curve is going to be the black one, so we need to move our cursor, move up or down until it's landed on that black line and you see the equation for that graph in your window. Hit enter and you'll see it will hop onto the intersection, and that's a 94. A 94. So we need to have, we don't just leave the answer at this, we're going to interpret this for a person who doesn't know what this is mathematically. A grade of at least 44% and up to but not including 94% will result in a B. Okay. So we want between 44 and 94%, including the 44% would give you a B, but not including the 94%. That would give you an A. That's it for this section. So go ahead and try that homework and let me know if you have questions.